Okay, welcome back. Our last videos where we looked at the introduction to calculus. Today we are going to look at how best we can find the differentials using the first principle. Okay, first principle defines a derivative as limit h approaching 0, then f x plus h minus f of x over h. In our formula here, this one, if we remember very well, we did functions. Let's say, for example's sake, if whenever we had the function f of x maybe equals 2x for argument's sake, when we are taught to find f of 1, what we usually used to do is where there is x in this function we put 1. So for this we could do like that and find the value 2. That is the same principle that we are going to apply here. When you look at this one, this is the original function f of x, and if we have, whenever we have a prime here, it means divide x, okay, or the derivative. So when we look at this one, we have the formula that we are going to be using when we are solving using first principle. Let's look at some examples. Let's say we have f of x equals x squared plus 1. Now we want to use what we call first principle. Alright, we use first principle to find dy dx or f of x prime. Okay, so what do? We are going to look at this function and relate that one to the formula that we have. We have f prime of x, which is equal to, now let's be critical here. We said where there is x in the function, our function is here, x is here. Where there is x, we are going to put x plus h and remove the original function. That's what we mean, divided by h. Alright, so we have our function x. Where there is x here, we're going to put x plus h, but the x we're talking about here is squared. So what do? We are going to square the whole statement here. Let's not forget that the function is not ending here. The function is plus 1 here. After we are done with the function now, then we remove the original function from here. So we are going to say minus, and make sure we protect in brackets. We are going to have x squared plus 1. Alright, then this is over h. Okay, allow me to introduce the limits. Sorry for that. We have x, then we say limit h approaching 0. Alright, don't forget to put this in brackets as we are saying. If you don't put this in brackets, it means we are only removing x from this whole statement, but we said we remove the original function from this. So whenever you have any terms here, you have to protect them in brackets, put in brackets, don't forget. Here h approaches 0. We are not going to replace h here and put a 0. Remember, we can't divide by 0. So we are going to find means that we are going to eliminate h in the bottom there. So look at this one. Let's use our basic concepts. When we expand this using our essential skills in mathematics, actually we are going to get x squared plus 2xh. Try it at your own time. Okay, but don't worry, you can put this as 2 of them and expand. Then we have h squared plus 1. Negative times that we are going to have plus 1 here, alright? Then minus x squared minus 1, alright? Then we are saying divided by h. Okay? Then limit h approaches 0. Okay, when we look at this one, x and this when added, they are going to cancel. Okay, this is negative, this is positive. This is negative 1, this is positive 1, they are going to cancel, and we remain with 2x h plus h squared over h. Now our desire here is actually to eliminate h so that we can replace. Look at this one, h is common here. We can factor out h and remain with 2x this side plus h, right, over h. H goes, we are going to have 2x plus h. And when we look at this one, we were saying the limit, okay, h approaches 0. When we put 0 here, the moment we are going to replace x here, the limit has to disappear and we get f of x prime equals, when we put 0 here, we are going to get 2x. And this is our derivative using first principle. Let's just check using our ordinary method. If we have this function, we said we are going to multiply the function here, the coefficient which is 1 here, we multiply by 2. So we were supposed to get 2, alright, x, and 2 here is reduced by 1. This is a constant plus 0. Alright, we find that we are still getting the same answer, but now we are using first principle. That's how we use first principle. Subscribe to the channel.